Hello and welcome to a brand new PSP tutorial, and in this tutorial video we're going to go ahead and go over some of the various things that we can do in our programs. And basically what we're going to be doing is checking for inputs and then responding to said inputs by updating the screen to show a new line of text every time that a button is pressed. So in this episode there's going to be no real setup that we need to do beforehand, and let's go ahead and get started with our programming languages. Programming languages will go in order from C, C++, Rust, and Zig, in that order. Alright, so for doing this programming tutorial in C, what we're going to do is go ahead and modify a few of the things that we've already had in here. First things first, we're going to do a while loop with 1 as our condition, which will always be true. And inside of this while loop, this is where we're going to go ahead and put some of our code for our updates. To start off, we need to actually go ahead and set up a few things here. And in order to use the controls, we're going to do include PSP control.h. Alright, that's great. Now that we've done that, we're going to go ahead and do SCE control, set sampling cycle. And we're going to set sampling cycle to 0. As you can see from the documentation that came up here, int SCE control set sampling cycle, int cycle is normally set to 0 and sets the controller cycle setting. So we're just going to leave it like that, as it is normally. And then we're going to go ahead and then do SCE control set sampling mode. So now that we've set the cycle, we have to set the mode, and it's one of the PSP control modes. So in order to do the PSP control mode, and then we have either analog or digital. So in this case, we're going to want analog mode so that we can have basically the full ranges of the analog stick. Now that that's done, one thing that we're going to go ahead and do is we're going to go ahead and declare SCE control data, which is a structure, so we could actually go ahead and do struct SCE control data. So we're going to create a struct SCE control data. And we're just going to declare that for now. And what we're going to go ahead and do is that every time we want to update, we're going to actually go ahead and call SCE control read buffer positive. So this will read if we have some new data to get. So and then it will wait if we need it otherwise. So we're going to go ahead and do pad data. So we're going to do the control data, which is our control data. And then we're going to go ahead and say that the count, so the number of buffers to read. In this case, since it's 1, we're just going to, since we only have one member here, we're just going to go ahead and pass it. So let's go ahead and do some very basic platform code here to test if something is inputted. So to test if something is inputted, we're going to do if control data dot buttons, and then what we're going to have to do is use the bitwise AND operator. And what we're going to do is we're going to compare it to the flag itself. So PSP control, for example, cross. If we do that, if this result is not equal to 0, so if it's greater than 0, it's going to actually go ahead and mean that yes, the button itself was actually pushed. So that means that we're going to go ahead and say, oh, if we're pressing cross, let's do PSP debug print, debug green print F, and then we're going to go ahead and print cross pressed with a \n. Cool, so there we go. We have the very basic thing here. We're going to go ahead and make a copy of that, and instead of cross here, we're going to fill in circle. So by doing that, we're going to do circle pressed. So this way we can now see what button was pressed, and then let's go ahead and open up a terminal instance, new terminal, cd to our C directory, and then run make. Could come across in a second, and there we go. We're going to go ahead and open up ppsspp, Then we're going to go ahead and open the directory. Go ahead and go into PSP tutorials and then C. Let's go ahead and run that. And now if we go ahead and press the X button, or sorry, I hit the circle button, but if I press the cross button, it says cross press, otherwise it hits circle and circle press. And you'll see that it goes ahead and loops through that depending on what button that you're pressing down. Congratulations on this very basic tutorial. You now have the easiest way to go ahead. Congratulations on the tutorial. You now have the basic way to read some of the static buttons. Now, what if you wanted to go ahead and press the analog buttons? What you would go ahead and do is you would access control data.lx or .ly, which is actually going to be signed data, which is between 0 and 255. 127 is the center point of where basically the middle is, and you can go ahead and convert that to where is the analog stick at. Furthermore, you can also get timestamp, which is going to be basically something that tells you what time was the data given at. That way you can compare two different control sets to see what order they are in. Alright, to go ahead and do controls in C++, it's going to be very much similar to the C code. To first off start with, we're going to go ahead and do PSP control as one of our includes here, so that we can actually access the control itself. Now what we're going to go ahead and do next is we're going to reformat this sort of boilerplate code. We're going to go ahead and run an infinite while loop, so while true, and then inside of this loop we're going to go ahead and run our main control flow. To go ahead and set up for it, we're going to do SCE control set sampling cycle to 0. As you can see from the comment here that was added, cycle, which is the cycle component, is normally set to 0 and sets the controller cycle settings. Next thing we're going to do is SCE control set sampling mode, and we're going to go ahead and do PSP control mode. And then in this case, we want analog, so we can actually measure the analog of the analog stick. Next, we're going to go ahead and declare some data here. So SCE control data is going to be our control data. So that's actually going to hold the information on our actual data structures here. Next thing we got to do is do SCE control data, the next thing that we're going to do on every sort of iteration of this while loop is SCE control read buffer positive. We're going to give a reference to the control data so that it gets a pointer, and then we're going to say that we only have one member here that we actually want to take data in for. Past that would be a buffer overwrite. Then, with our next thing here, we're going to go ahead and determine whether or not a button is being pressed. To do that, we're going to create an if statement with control data.buttons, and then we're going to use a bitwise and we're going to AND it against one of the buttons that we have. So PSP control, and then, for example, we want to go ahead and do cross, and there we go. And if the cross button is held down, this AND will be greater than 0, so therefore we'll actually have something inside of here. So whatever we're going to put inside of here is going to be PSP debug screen printf, and that's going to print data to the screen. We're going to say cross press with a \n there, and then there we go. And let's go ahead and do triangle as the other one. So triangle. Yeah, there we go. Triangle. So now that we have this very basic setup here, we're going to go ahead and create a new terminal instance. And we're going to go into the C++ directory, run make, which makes our entire thing here. And then we can go ahead and run ppsspp. We're going to go ahead and open a directory from our disk. We're going to go ahead and open the PSP tutorial, and then we're going to run the C++. Now we have a blank screen. If we hit the cross button, it says cross pressed. If we go ahead and hit the triangle button, which I don't know where that's bound to, there we go. We have the triangle pressed. So if I go ahead and run here, we can do cross press, triangle press, cross press, triangle press. And it will show up an update on the screen. This little black area here is where the newest line will be written to as it's being cleared. Either way, that's going to be a successful program in C++. For example, if we wanted to go ahead and access the control data for our actual analog stick, all we do is do control data.lx or .ly to refer to the left X and Y positions of the analog stick. 127 is considered the center area of the analog stick itself, and you can go ahead and normalize those coordinates down to -1 to +1 if you want to use floating point numbers. Alright, so to get started with this tutorial in Rust, what we're going to do is we're going to first get rid of this sort of statement here and set up for our main application. We're also going to go ahead and do use PSP sys, and then we can do SCE control data, control buttons, and control mode as the main things that we want to go ahead and use here. Of course, it's going to say that it's unused right now, I'm betting. Yep, it says they're unused. Next thing we're going to do is create an unsafe block here. Most of the PSP system APIs are unsafe. Next thing that we're going to need to do is then call, we're going to go ahead and do PSP sys SCE control. And then what we're going to go ahead and use is do SCE control set sampling cycle. We're going to go ahead and set the sampling cycle to 0. And then the next thing we're going to do is PSP sys SCE control set sampling mode to the control mode, and we're going to use analog in this case. This way we can get data from the analog stick itself. Next thing we're going to go ahead and do is we're going to go ahead and create a control sort of pad, which is going to have all of our data that we're going to be reading from the actual controller or the control buttons. So we're going to do control data in snake case is equal to a mutable reference to the SCE control data, and we're going to use the defaults. And that way we now have this control data sort of member here. Next thing we're going to do is create a infinite loop. So actually, we're just going to go ahead and do loop, since that is a Rust keyword. And then we're going to go ahead and do PSP this SCE control read buffer positive. We're going to pass in control data, and then we're going to go ahead and have a count here. The count is the number of buffers to read, and in this case it's just going to be 1 since we only have one member there. Go ahead and work with the data that we've now read. We're going to go ahead and do an if statement with the control data. And we're going to use the buttons sub-element of that. And inside of that element, we're going to see if it contains the control buttons and then cross. And then if that is the case, what we're going to do is PSP dprintln macro to go ahead and print contains cross. Likewise, we can go ahead and do if control data dot buttons dot contains control buttons circle. We can go ahead and do PSP dprintln contains circle. And this way, this is a very simple way of going ahead and taking a look at the data that we have here. So what we're going to do is go into the terminal. We're going to change our directory to Rust and then run cargo PSP, which should go ahead and build without any errors. Next thing we're going to do is open up ppsSpp, and we're going to go ahead and open our Rust build directory. We're just going to scroll down here, PSP tutorials, Rust, target, Pony PSP, and then we're just going to select debug here, and it's going to launch up. If we hit the cross button, it's going to do that, and if we hit the circle, it's going to do that. And we can go ahead and alternate, and you can go ahead and see that we have a working input detection system. In the future, if you want to go ahead and check other data, you can do control data.lx for the x axis of the analog and ly for the y axis of the analog. This should be in a U8, which goes ahead and has 127 at its center. You can go ahead and normalize this and put this into whatever coordinate space that you need for your analog stick handling. Alright, to go ahead and get started with the Zig portion of this tutorial, what we're going to go ahead and do is actually go ahead and look what's inside of Zig PSP. Inside of here, we can go into the source directory and then open up PSP and show that we have these different folders. Inside of the SDK folder, we have all of the definitions for everything, and it's basically just the interfaces. So we can see that we have all of these different structures and all these different functions, each one with their own sort of documentation here. We also have some of the safety wrapped methods, for example, control set idle, cancel threshold, that drops the SEE prefix here and also allows you to use error unions in order to go ahead and do certain checks like that. So knowing this information, let's go ahead and start off by adding in using namespace. So this is going to import into our current namespace. We're going to go ahead and do source PSP include, and then so whatever's in the include directory includes both the actual implementation and the actual initial sort of layout as well. So we're going to do PSP control.zig, and that way we ensure that we have everything that our application needs. Next thing we're going to do is going to restructure this a little bit. We're going to create an infinite loop here, and we're going to put things in there momentarily. Next thing we're going to go ahead and do is SCE control, and then what we're going to do is do set sampling cycle. We're going to set that to 0, and then we're going to do control set sampling mode, and this is a safety wrapped method, and we're going to do PSP control mode. I believe that's what it's called, or control mode. Yeah, PSP control mode dot analog as our primary mode here. Both of these are actually going to return results that we don't really care about, so we're going to discard it using the underscore equals syntax in order to discard data members like that. Next thing we're going to do is create a variable, and this is going to be our control data. It's going to be of type PSP, SCE control data, and we're just going to set it to undefined for now, just so that we've reserved the space. Next thing we're going to do here is then going to go ahead and do underscore equals SCE control read buffer positive, and we're going to go ahead and pass in the reference control data and a 1 there. And what that does is it reads one instance of SCE control data into the buffer here, which is control data. Now that we have that, what we're going to do is we're going to do if control data dot buttons and, so bitwise and, is going to do the enum to int, so PSP control buttons, and then we're going to go ahead and do cross and say that's not equal to 0, which means that we actually did go ahead and pick up something here. And what we're going to do is then do psp.debug.print. Then we're going to say cross was pressed. And then we're also going to go ahead and copy this and do it for circle. And then say circle was pressed. And that way we can go ahead and do that. Create a new terminal, and we're going to go into cd zig, and then we're going to run zig build as our command. What did I do here? Oh, I forgot the R. Well, that was very silly. Alright, there we go. We're going to go ahead and open up PPSSPP here, and we're going to go ahead and File, Open Directory. We can go ahead and open up, oops, there we go, PSP tutorials, and then zig, and then it's going to be in this folder. Give it a second, and then if we go ahead and press cross, cross was pressed, and if we hit circle, circle was pressed. And there we go, we had a successful tutorial in zig. If we want to go ahead and access independent members of the control data here, if we went to SE control data, to use the analog stick, you're going to use LX or LY. This is the X and Y of the left analog stick, is of type U8, and 127 is the center. That way you can go ahead and normalize it. Its range is the full range of a U8, so from 0 to 255. And that way you can go ahead and actually read the analog data itself. I hope you've enjoyed this tutorial as far as it's gone so far. So now you should be able to go ahead and actually work with whatever language you want, and also be able to go ahead and read and use inputs. In the next tutorial, we're going to go ahead and be covering some basic 2D frame buffer drawing. So basically just drawing directly to video memory and how to do it in each sort of language. What that will cover is basically going to be being able to write individual pixels onto a screen, draw rectangles, and basic things like that. It's not the graphically accelerated way, and it does create some screen tearing issues, but it's going to be a very, very basic way of getting into some very simple software 2D rendering. After that, we'll go ahead and actually cover some of the things inside of the GU or the graphics utility to go ahead and use much more advanced versions of this sort of thing in your language. Thank you guys for watching. Please like, comment, subscribe, and I'll see you guys in another tutorial video.